Hello and welcome to the first webinar of Louis Belet. Um, it's the third, yes, already because we already put that in place for French speaking, German speaking. So now it's your turn in English language to follow this webinar about the 1620F, our finishing end mill that allows you to have outstanding surface finish during your milling operation in stainless steel. So I'm Hervé Baour. I think that most of you know me or saw me anywhere around the world. I am the sales manager for international as well as international business development manager. I'm working for Louis Belet since almost 7 years now, and of course my business and my work has changed radically since beginning of this year due to the well-known COVID-19, and we need to reinvent ourselves in order to get in touch with you and keep you updated with a new products and new techniques that our community or our company can provide you with. So today we'll go through a presentation. You will have the opportunity to ask you some questions, to ask us, excuse me, some question or ask me. There is a Q&R section in the interface that you can see, and as well you will have the possibility to answer to some polls. There will be 3 of them during this 15 minutes live session, for which we try to better understand your needs and where you do come from in terms of technology or markets. So we'll start with the first poll, and it will ask you what type of industry are you working in. So let's start the first one. I will let it run for some time, and I will first of all show you the tool we will talk about today. So it's a full flute finishing end mills coated tool, as you can see, and we will go a bit more in detail about it with the first slide. This is the tool we will talk about. I just showed you. Where does this come from, basically? So most of our customers are from originally from the watch industry, and they had some challenges because the finishing or the polishing section of the work or the operation was highly costly in terms of time, and of course in terms of dollar afterwards. And they asked us, can you develop a tool which is which allows us to minimize this finishing operation, or if possible, remove it completely. So we developed we took everything in our hands in order to define what can be done in order to achieve this challenge. So we took everything we had in mind in hand in order to have some shiny flutes, sharp edges, edge preparation on the side, a completely dedicated coating for the stainless steel, and basically it led us to this kind of tool that you can see rotating in front of you. In our portfolio, you will find it standard from our. You will find it standard in our list of product, and it starts from diameter 2 up to diameter 12. The cutting length is generally 2 times D. as I asked you before, or as I mentioned, the industry asked us, what is or how can we do to minimize this finishing share or rate. So I will open a second poll, which will ask you on how can we or how much of your cost is the finishing operation I mean cost, basically. So is it a lot of your cost or your overall cost? Because as said, so if you want to have a minimum time for finishing, for polishing, you need to have a perfect milling surface state. So we had, for instance, customer which had up to 50% of the total cost used only for the finishing operation or polishing operation. And you know that the more you polish, the more you do this operation, the more you round the edge of your part, and this is definitely not what you would like to have. All right. So we will go deeper in terms of cutting speed and cutting operation. But before doing that, I need to mention that today the modern machines or all the machines are precise. All these centers of operation are doing outstandingly, and they are performing really well, all of them. However, should you use a Vimama Codel, a Bimotech, or any kind of other centers, they all are different. So they do have a better rigidity. They do have some, speeds, run out and the spindle. We are talking about micron, of course, but all of them are a bit different. So for our example, where we will show it working live, we used a cutting speed fairly high at 180 meters per minute. And it was working well in our setup. So our setup was a Vimama Codel for one machine. So the beauty of the thing, or the wheel fine tuning, lies on the details. And in our case, the details are really the feed per tooth. You need to go fast, but not too fast. And the bigger thing to take care of is that the chip is not smaller than 2 micron. Why is that? If the chip is too small, it goes behind the cutting edge, and we call that in French patinage or sliding. So this slide will make a deposit of material on the cutting edge, and it will limit, or it will degrade the life duration of the tool. So let's have a look on my slide. This is a kind of a wristband part, a bit bigger. You can see it here. I will show it to you in a larger side afterwards. And we took what was working pretty well on our setup, once again, was a cutting speed of 180 meters per minute. The feed per tooth was something between 15 and 30 micron for a flank finish, and from 5 to 20 micron for the bottom finish. This, of course, is for a tool with a diameter of 6 millimeter. Then the other thickness before finishing, we took it 500 or 50 micron. Why is that? That's where we saw best results. Then the AP or AE was something like 0.05. at 2 times D and 0.75 times D for the AE. So I can show you maybe now how does look the part in real. So you can see the finish was made really with this tool, and I can say that it's really shiny and really impressive in terms of roughness. We will come back on this pretty quickly. What I will show you now is how it was done and how it looked. And this is how it looks like. So you see the cutter working around. You see the difference between the pre-preparation or pre-milling and the finishing. And you can see it maybe the second time. You can see that once the end mill is passing over the face, the face is looking much brighter, much shinier. So the parameters we use, the set is something like 180 meters per minute, which gives us a revolution speed of 10,000 RPM with a feed rate at 550 meters per minute. And the tool used there is our 1620F with the diameter of 6 millimeters. We can see the contouring machining of the part, and the chips are well fragmented, so the chips are really small. What we didn't put here was a lubricant in purpose. I mean, of course, for a purpose that you can see the machining. And what you can barely hear, maybe I can put it louder. While machining, the sound is okay. It doesn't make a lot of noise or a lot of low vibration, which indicates at the first sight that the machining is doing okay. What we can see now is the result slide. So what we do see here are two machining. On the left-hand side, it was done with a standard end mill with, I mean, a non-finishing end mill. So you can see stripes on the face, and on the right-hand side with the finishing end mill. Both cuts were made with the same parameters, cutting parameters, so it shouldn't be that many difference in terms of machining itself. So all the geometry, all the coatings, all the small geometry details that we put in this 1620F end mill, it gives us the ability to have a much more shinier surface than a standard end mill. So you can see that it's really near to a polish finish. So you see a lot less stripes. And when you do the polishing, usually, so when you do insist in polishing, then I mean, the dimension are modified. The dimensions are modified, and also the edges they are not sharp anymore of your part. So the more near to the polishing end surface you are, the less polishing operation you have to do, and the more sharper edge you can have. And also in terms of dimension, you still are in the micron if you have less polishing operation to do. So this has been requested by the watch industry, as I said at first. But through the time, so different other customers are using this kind of tool as well. For instance, in the medical application, like for hip implants or knees implants. So the more closer you are from the end dimension or the end state you wish, the less operation you have to do in polishing. So it saves you a lot of cost, of course. Yeah, you know us as a supplier of solution, and we do have these standard tools. But of course, we can take all the advantage of this standard tool with geometry or custom shape tools. Yes, of course, you can have like, for instance, you can see on the slide, you can have a special dedicated geometry that you would like to see, and we can implement the coating, the edge preparation, and all the details that are that were developed for this tool to be put on this kind of tool. It drives me to the end of or the last poll. And the last poll is the material. So I would like to know what kind of material you do machine. So because we are talking here about a tool for the stainless steel, but what other material would you like to see for this kind of tool? We know titanium is widely used and more used in different industries. Let's see what the polls gives you as an answer. I think we make about the more or less the most of the round of the subject. So I don't know if you do have some questions. Let me see if I do get some question. I do have 2 or 3 actually. So the first one is a semi-finishing operation mandatory to use this tool? This tool doesn't really need a semi-finishing operation. Of course, it is meant to be used as a finishing tool, so you better have a geometry near to the end dimensions. But having an over thickness of 0.05 or 0.1 should be something correct or coherent with what you need in order to have the best finish of your end plates and surface. So I hope this answers the question. What is the second question? Does the cutter support a pass width greater than 50 micron or 0.05 millimeter? I will say yes, but as said before, so I think that an over thickness of 0.05 millimeter, between 0.05 and 0.1 is the best, because you still have, I mean, meat to eat, and the cutter can really cut at its best this kind of over thickness. But from a standard, I mean, from a real point of view, I mean, this tool was developed based on the 1620 series, which is an end mill for the stainless steel, and so we adapted it for doing the 1620F. So it is an end mill that you can take larger pass. However, the more you give, or I mean, if you go over the 0.1 millimeter, it will, I think it will lower the life duration of this tool. So yeah, between 0.1 or 0.05 and 0.1 should be should give you the best results. Another question: does the 1620F work in other material? This is a good question, and for a small story, I would say that we developed a brass tool, and one of our customers tested it in titanium, and it was surprisingly working outstandingly. So I would say that it might work, but we haven't tested. Let me write it down. I will ask my colleagues from R&D to make the test with maybe another coating or slight other geometry. But we will try to do that and give you some feedback. Let me hear. I do have a question here. What would be the ideal depth of cut, so AE, to get a mirror finish? Well, I think it was linked something like similar to the other question. I think you will get best result with AE between 0.05 and 0.1. However, I doubt that you will have really a mirror finish, because mirror finish can only be reached with a polishing or maybe a monocrystal diamond tool. So it will be difficult to get a mirror finish with this tool, but you will get close to it, I would say. Another question: what type of edge prep is maintained? Well, this is a recipe that we do have in our in-house. Of course, the edge preparation is a science. We did a lot of tests in order to have or to reach this kind of quality, and this is kind of a secret. But I mean, the process is stable, and it is kind of a recipe, and this recipe is given for this series of cutters, which gives an edge prep consistent in the whole production series. I hope I give the answer you wanted. How much RA is possible to achieve? The RA that we measured was around 0.15. So it's not a mirror finish, if we come back to the last question, but it is for a milling operation. It's already really outstanding, I would say. So we measured down to 0.1, if I'm not mistaken. But yeah, 0.15 is something that we can reach, or we could yeah, think to achieve with this kind of tool, at least with our machine. Maybe you can have a better machining centers, more rigid, that allows you to go even higher in terms of RA. Will this webinar of the cutting specification display be available to reference for programming my machine? Yes. So we will. I will, after this webinar, I will send you the link to the video, because it's recorded. You will have the possibility to see the video again, and also the slides. But if you wish, you also can send me email to go deeper into this discussion, and I definitely can link you to our R&D team to give you dedicated or custom cutting parameters. Another question, does it produce burr on the corners? That's a good question. Um, it depends of what you call burr, because I don't know if you see it, it wasn't touched. It's difficult to see. You feel that it's sharp, and I mean sharpness and burr sometimes is really near. Um, it doesn't cut you, so it is regular. I would say that if there are some burr, it's really limited. You do not see, even on the microscope, you do not see a lot of irregular, I mean, not flat surface. So I would say rather no, but I do not say it clear or I mean 100% sure that it will not create a little burr. What it could also do is the thicker or the most material you do cut, so the AE, the bigger it is, then it will create more burr afterwards. The last question I have in my screen is, what tool life can be achieved on stainless steel material in terms of meter? This is a good question. I do not have the answer handy. What I can tell you is this was shown on an exhibition. So we had a small machine machining this part, and I'm not 100% sure if we changed the cutter or not, but during the whole week we did produce with, I would say, with the same cutter. So this is a 10 millimeter, 10 centimeters, so 100 millimeter, or 5 and 5. And I think we produced something like 200 of them. So 200 times 10, 2000 centimeter, 20 meter is something which is reachable easily. The cutter was like new. It's not an answer. I might ask our R&D team to give you a more precise answer, but it gives you still an idea. It will not be 10, it might be 100 or 200 meters. I really cannot answer this question, but I think it's more or less in this range. I will come back to you to give you some more information, but once again, it also depends on the part you do machine. It also depends on the AE or the cutting parameter you are using. It also depends on the machine. It's really hard to answer this kind of question, but I will try to get more information about that. All right, so I do not have any more questions so far. So I think it's coming to the end of this third webinar. I hope that you liked it. Arno, I wanted also to get back to you about the polls I proposed you. So just to give you some information about the industry. So the people were following this seminar or this webinar. So we had about 45% who are active in the medtech, 36% in the dental industry, 27% on the watch industry, 64% from the automotive, 36% on aeronautics or aerospace, and 27% other industry. Second poll was what is the proportional cost of your finishing operation? So 40% were, did answer from 0 to 10% of the whole product cost, 30% from 10 to 20, 20% from 20 to 30, and 10% above 30%. So you see this, I mean, we have like something like 30% who have some issues, let's say, with the cost of production for this finishing part more than 20%, which is, I mean, pretty high. And for the last poll about the materials you do machine, so steel and titanium. So titanium is the highest, has the highest rate with 69%. Then steel with 62%, aluminum 38%, non-ferrous material with 31%, precious material 15%, and composite 8%. So it's kind of interesting. It's kind of interesting information that you shared with us. It will also guide us for future development. I do see maybe one or two other questions before closing the webinar. So what is the order code for this item? So it is 1620F series. I can send you the data sheet for with the detail of the diameter to all of you who followed the webinar. So that I do not forget, I write it down. Data sheet. Okay. Can you explain about trochoidal milling can be used? Do we have any impeller machining taper and mill? I think that once again, this tool is not meant for really, I mean, going into the material and do a shape like any other end mill. So I would rather use it as a finishing tool for contouring and not really a trochoidal machining. So for this, I would rather use another series from us, maybe a 1620F for stainless steel, 1620, excuse me, 1620 for stainless steel or others. We can discuss. You can send me an email asking me for other cutters for stainless steel or other material. How much depth can we take for small diameters and mill like 1 millimeter for key west slots? So the end mill has cutting lengths of 2 times D. So if you have a 1 millimeter, well, we start standard. We start from 2 millimeters diameter, so you will get a 4 millimeters cutting length for the contouring. All right, so this time I think I did the round of the tour of the questions. So I thank you once again really much for your attendance. I hope that you liked the webinar. We will do others. If you have some interest in different other webinar material, tool, anything you can ask, we will take it into consideration for the next webinar. I hope that this cutter, this 1620F cutter, will help you in doing your finishing operation. Should you have any other need, you can directly contact me. I will share my screen for you to get my details, my contact details. Please also do follow us on our social networks like LinkedIn, for instance. You get a lot of information on this kind of social media. And the ending word will be, of course, stay healthy. I hope everybody goes well, and I hope it will stay like this for you and your family. Take care of you, take care of yourself, and don't hesitate to machine with our tools. All right, thank you very much, and have a nice day, evening, or morning. depending on which area you are all over the world. Thank you very much. Enjoy.